more about all this at the end of the video, but right now let's get to the video. Now we apply these ideas to the task of determining how many 4-element subsets there are of the set of numbers 1, 2, 3, 4, 5, 6, 7. Well, there are 7 numbers here. We have to choose 4 of them to get a 4-element subset. So the number of possible subsets is the number of ways of choosing 4 out of the 7. And the order in which numbers or elements are listed in the set has no effect on what the set is. They can be listed in any order, so order doesn't matter. And of course, there's no replacement. If we were to choose the same number twice, even if we wanted to list it twice within the set, that element would still be only in the set one time. It's either in there or it isn't. So order doesn't matter, no replacement. We're choosing 4 from 7, so the number of ways is C of 7, 4. Now, another thing we did in our class today is one of the questions in the quiz, very straightforward, evaluate C of 8, 2. Well, using the formula, we can easily write what we mean by C of 8, 2. N is 8, R is 2. We put N here, then we're going to have an 8 here. We put an 8 here, there it is. We put a 2 here, there it is. And we put another 2 here where R is, and there it is. So that the formula translates directly over into this expression, and then we evaluate the expression. Now, to evaluate this expression, we want to write out each of these factorials. So you should do that before you watch. Well, I'm going to write it out. You should write it out yourself before you see what I do. So pause now and do that. Now, the first thing I've done is I've written the 8 factorial. And that factorial isn't written real well up there. 8 factorial as 8 times 7 times 6, etc., down to 1. And then instead of writing out these factorials, I want to be careful. I want to subtract the 2 from the 8 to get the 6 so that I know this is 6 factorial. And then I'm going to multiply that by the 2 factorial in the denominator. So now we want to write these factorials out, so you should do that. Well, here's what you should have written. I've used an asterisk here instead of a dot just to delineate the 6 factorial from the 2 factorial. It wasn't necessary to do that. Could have grouped them. I could have just written it all out with dots or with asterisks. Okay. Now, notice that I have everything from 6 down to 1 here and everything from 6 down to 1 here. So that this and this, well, this is going to divide into this, giving us just 1. So now we know that this is just 8 times 7 over 2 times 1. Okay. Well, 2 goes into 8 4 times. So that could be written as just 4 times 7, which is 28. And I'll comment that if you've seen Pascal's triangle, you will know that this is going to be the number that appears in the n equals 8 row in the r equals 2 position. You're going to have that number 28. Now, you might not have seen Pascal's triangle by this time, but when you do, hopefully you'll recognize what you saw here. Okay, if you're still with us, the address at which you can find access to well over 2,500 videos, more than 300 hours, is http://vhmthphyd.vhcc.edu/vmenu.html. Videos covering all college transfer courses taught at my institution in mathematics and physics, including calculus-based engineering physics, up through multivariable vector calculus and introductory ordinary differential equations.